Dear friends, good evening. I am Balakumar. Now, let us try to learn a small concept which we are going to see tomorrow. I will brief it in this video. Let us see it in detail tomorrow. In the problem sheet 7, the first problem is given like this. A man raises a 10 kg joist of length 4 meter by pulling on a rope. Find the tension in the rope and reaction at A. So this is the joist which is pulled by a man by using a rope. The rope is some tension is acting in the rope, and the weight of the object, the bird, a joist is 10, mass is 10 kg, so its weight will be 10 into 9.81, which will add at the center. Now we have to find out the reactions or the forces acting on the body. If we are asked to draw the free body diagram for this, we will try to draw the free body diagram like this. Let this be the joist acting, and this is point A, and the W, which is the weight 10 into 9.81 kg, is acting at the center, just at the 2 meter. Now a force tension is acting, so the tension force is acting and weight is acting downwards. And now at this point A, we have to draw a reaction. If I ask to draw the reaction at A, at the first time many of us will try to draw like this, that is reaction RA will be acting along the line of the action, which we will be assuming in this manner, but this is not correct. This is wrong. We should not, because when an object is standing still, where only its weight is alone acting and it is at equilibrium, then here the weight will be acts in the downward direction and the reaction will be acting in the upward direction along the line of axis. It's okay. But in this case, where the object is pulled down by a rope and weight is acting downwards and it is already 45-degree incline, so the reaction at A will not be along the axis. So how will be the reaction? Which means now we are interested or focused on finding out the direction of the reaction. Here we have to understand the concept of body under equilibrium, equilibrium body under 3-4 system. Which means, what is 3-4 system? In this given example, yes, a weight is acting downwards, tension is acting in this direction, and reaction will be acting at some direction but not in direction. We have to find out the direction of this reaction. So we know that there will be 3 forces: T, that is tension; W, weight; and a reaction at A. So in this type of problems where a body is acted upon by 3 forces and it is at equilibrium, we should know one main concept, that the lines of action of forces will be concurrent, which means there are 3 forces, T, W and RA. These 3 forces have 3 lines of action. These lines of action will be concurrent at one point, or they should be parallel. This is the only condition to find out the direction of the reaction. Once again I am repeating, if a body is subjected by 3 forces and it is at equilibrium, then the lines of action of those 3 forces will be concurrent, which means the lines of the forces will be meeting at one point when they are transmitted along the lines of action. Once again I repeat, the lines of action will be concurrent, or the forces will be meeting at one point when they are transmitted along the lines of action. So applying this condition, let us take this problem. Yes, let this be the axis of the joist, leave it. This is the joist, this is the tension T, and this is the W weight. We can move the W along the line of action as per principle of transmissibility of force. Then if you move along, this will meet at one point. Now join this point and the point A. So draw the line of action, and reaction will be along this line of action. It will not be along the axis of the joist. This will be along the line of action, which means the line of action of RA, the line of action of tension T, the line of action W will be concurrent at one point. Say this point be O. So this is the condition. This is the condition. So this is the condition for a force, three force body which is at equilibrium. So once again, in clear diagram version of diagram, if three forces T, W and X, the lines of action of these forces are concurrent at O. So W can be moved along the line of action, T can be moved along the line of action, and RA can be moved along the line of action so that it meet at one common point O. So the direction of reaction RA will be in this fashion, not will be along the axis. So with this means, how can we find out the angle? What should we do? Okay, it's very simple. Try to resolve these forces. Let this be RA. If we resolve this force, we will get HA and VA. So now forget RA, we have HA and VA. So now applying equilibrium condition, we can find out HA and VA. After finding out HA and VA, we can find out RA, because RA will be resultant of HA and VA. So this is how we are going to solve this problem in tomorrow's class. And there is another one special condition. Okay, this what happens when three forces are acting on a body. What happens when two forces are acting on a body which is under equilibrium? See, assume that it's a body on which two forces are acting, but still it is in equilibrium. What should be the conditions, or what are the conditions? There is three conditions. The two forces should be of equal magnitude. Number one, equal magnitude. Number two, they should be collinear. Number three, they should be opposite in direction, which means when a body is subjected to two forces acting on them, the two forces must be equal in magnitude, opposite in direction, and they should lie on the same line of action. This is a condition for two force body system. And for three force body system, the three forces, the lines of action of three forces must be concurrent or parallel, and most of the cases which we are solving, the forces will meet at one point, which means the lines of action will be concurrent. So we can solve this problem based on this concept. We shall see it in brief in detail in tomorrow's class. Thank you. If any doubts, you can ask in tomorrow's class. Thank you. Good day.